Welcome back everyone. In this video, as promised in the previous one, I'm gonna reduce all this duplication that we have here as per our tradition. So we always start with a flat model and then we go ahead and improve it. Okay, if you notice, we are having like 90% duplication. We are repeating the same thing. So for router 1, as we have it here, and it's divided by this delimiter, we are just having a different name, IP address, loopback IP, and you can see it is happening for router 2 as well. Now let's go ahead and fix this. Let's close this for a second, and also let's make a split here. And I think it's better for me to get out of your way, so see you in a while. Okay, so we need everything that is here to configure OSPF and a loopback interface on a router. So why not just go ahead and put it in an implementation first. Let's say this is a implementation. Let's call it OSPF for router. We are going to define this router very soon. Let's also end it. Okay. Now we need to define the router entity. Entity router. Let's close it as well. Okay, what do we need? What are the different things? So on the right, if you notice, we need a name. Let's just put it here. It's a string. What else do we need? We need a management IP. So let's go with std IPv4 address. I'm calling it mgmt IP. Okay, we took care of this. What else do we need? We need an IP address. So let's call it interface IP address. But since it's a little bit different, the formatting in comparison to the IP online 16, I need to make or use another type, and that type is also in our standard modules, and the name of that is IPv4 interface. Let's call it interface IP. What else do we need here? So we are having a network for our loopback interface. I'm gonna call it loopback IP. All right, so std IPv4 network. Let's call it loopback IP. Loopback IP. What else do we have here? Okay, we took care of this. We have a network here and a router ID. So let's go with the router ID first. The router ID is gonna be the IPv4 address as well. Router underscore ID. And then we need this network here. For the network, we go with IPv4 network. And if you notice, it's inside of a list. So I need to also specify it in the type here. And by doing this, we are achieving the goal. So we are always expecting a list of IP addresses. All right. Let's call it network. Here we go. Purya from the future here. Just wanted to point one thing out, and that is, since we are dealing with a list here, it would be better if we had named this networks. Anyway, back to the video. See you. Save. Now I need to implement this router entity using this implementation. And the way we do that is saying implement router using OSPF implementation. Here we go. So this is all the logic we needed. I just need to go ahead and use these fields in our implementation. Let's start doing that. So let's go up here. We'll start with the name. So this is gonna become self.name. The IP address is gonna be self.mgmt IP. Then we are having an address here. This has to be self.interface IP. For the loopback, we do the same. Self.loopback IP. For the network, you guessed it, self.network, and the router ID is gonna be self.router ID. Let's also get rid of these comments. We don't really need them anymore. Let's fix the formatting as well. So this is all the logic we needed to deploy our OSPF on our routers. So I'm gonna go ahead and remove all these lines here for the second router. Now we need to instantiate our routers. Okay. By the way, let's also fix these names here. We no longer have any R1s. We can say router instead. And for the OSPF also, we just resort to calling it OSPF. Here we go. Now let's instantiate our router entities. And how do we do that? We call this here and feed all these information to it. Let's say router 1 is equal to router. The name is gonna be router 1. The management IP is gonna be 10.11.1200. The loopback IP is gonna be 10.20.30.40/32. The router ID is 172.16.1.1, and then the network is going to be a list containing 172.16.1.0/24, and this should do. Now we can just grab the same thing and make a new one. We just call it router 2. The IP is 200. The loopback IP address is 50.60.70.80/32. The router is gonna be 2, and the network is the same. Okay, if you notice, the network in both router entities is the same. I just wanted to show you that you can choose how you provide these values. You could have it in the implementation itself here, like hard code it, or you could just dynamically set it like this. Okay, let's compile this and see if I've made any mistakes. Heading back to the terminal. Let's say Inmanta, and let me get back to the screen so you don't miss me. Here we go. Inmanta attack VB compile main tag F main, that's CF. Am I in the right? No. Inmanta tag VB compile tag F main.cf. Line 10, I have made a mistake. Let's see. Line 10. Oh, I have missed the colon here. Save. Let's go back. Inmanta tag VB, compile, tag F, main.cf. What did I miss again? Router in line 50. Let's check it out. Router. We don't have a router. It should be router ID. Did I make it very clear that it's a Monday? There you go. Alright, let's fix this and this, and I'll double check if I miss anything else or not. Looks like I'm missing interface IP as well. So let's quickly fix that too. Interface IP is equal to 172.16.1.1/24. And for this guy here, we should change it to 2. Here we go. Looks better. Let's compile and see. Inmanta tag VB, compile, tag F, main.cf. Let's clear the screen. And it compiled fine. Now, next thing, we need to go ahead and export it to the server. Tag F, main.cf. That is done. We can head to the web console. And here we see the resources. Now it's going to take some time till they get deployed. I'm going to pause the video and get back to you once it's done. And one point to mention here is, since I rebooted my PC and we were working on containers, there are no configurations anymore, so there will be fresh starts. Okay, a few seconds have passed and everything is deployed. Now we can go ahead and check the configuration on the routers and verify that everything is working fine. Let's head back to the terminal. Okay, let's go with this guy here. Docker exec tag IT. VyOS. By the way, I could just connect to their IP addresses, but I just decided to go with this approach for now. Let's show the configuration. OSPF is here. Everything is looking good. And this is my loopback interface. Show IP OSPF neighbor. I can see my neighbor here and the route should be there too. Here's the route as well. Ping 50, 60, 70, 80. Beautiful. Let's exit. Check the same thing on the other one as well. VyOS. Show configuration. All good. Show IP OSPF neighbor. Perfect. Show IP route. Here's our here's our neighbor, and we can ping it 10, 20, 30, 40. Here we go. So you could see how easy it was to convert this model to a more efficient one. I would like to keep this video very short. In the next one, I'm going to show you how you can add more features to the VyOS module and maybe challenge you to do so yourself. But I'm not going to spoil much. Let it be for the next video. Thanks for watching and see you. Bye.